Hello, everybody. Welcome to this session for the pre-entry examination preparation with particular emphasis on numerical skills. My name is Norman Enyang, your tutor for numerical skills. So today we are going to look at the exam which was done for the pre-entry on 13th April 2019. That's the 2019 pre-entry examination with particular emphasis on the numerical skills section, as always. So as you can see, the examination was done between 9 a.m. and midday, which is the traditional time for the pre-entry examinations. There are 3-hour exam, which involves lots of disciplines tested. We have about 5 sections. The first of those is the aptitude section. And then we have the reading comprehension section, that is section 2. Then we have my section, which is the numerical skills section. Then we also have the general knowledge section, and then the analytical writing skills section. So as always, the examiner is kind enough to give you an estimate of the time, the projected time duration for each section, and particularly for numerical skills, we have 35 minutes. 35 minutes in which we have to answer 10 multiple choice questions there under the examination condition. So meaning that we have about 3.5 minutes, 3.5 minutes for each question on average. Obviously, there are questions that will take much less time, as we shall be able to see, and there are those that could stretch you a little bit, but all in all, any additional time spent on each section will mean you have less time for the other section, and hence less time for you to do a particular complete a particular section, and eventually less time for you to complete the exam. So the instructions, as always, are given to you. Students can read this on their own. I will as always be able to share with you both obviously the recording and then also my worksheet in which you can access the instructions together with my working. So let's get straight into the exam. So section 3, as I said, is the numerical skills section, which is worth 20 marks. 20 marks coming out of 10 multiple choice questions in 35 minutes. I think it is not asking for too much from you. Each correct answer gets you 2 marks within 3.5 minutes. I think that is very fair. So let's look at the questions, have a quick overview in about 5 minutes, as we have always been doing, and then get to the working there together. So question 1, okay, we can first read the instruction. For questions 1 to 10, choose the right answer from the choices provided. Question 1, 6 towns A, B, C, D, E, F are equally spaced along a straight path. Joan drives from town A to town F and then back to town A. At what point has she completed 70% of her drive? So you can see Joan is moving in between 6 towns, and the to and fro. So Joan has a to and fro journey. Obviously the to journey is a half of it, and the fro journey is the other half. But the examiner is asking us, at what point has she completed 70% of her drive? Of course, that is on her return. That is just by counting the points and know how many points are between A, B, C, D, E, and F. There are probably 5 points. When she's So 5 points going, 5 points coming back. There you have the answer. We shall come back and do the detailed working. Question number 2. Kato bought 3 lemons, 2 oranges and 1 mango for 10,000 shillings. Waswa bought 1 lemon, 2 oranges and 3 mangoes for 7,200 shillings. How much does it cost to buy 1 lemon, 1 orange and 1 mango? Very simple logic that this question is testing. We need to form very simple equations and then know what is the relationship between 1 lemon, 1 orange and 1 mango. Very easy question there. As always, we get an overview. My work is not just to tell you that this question is easy and I don't do it. I'll come back and do it and you'll see how easy it is. Question 3. Recycling 100 kilograms of paper will save 24 trees. Yeah, these are, environmentalists. They really want to save the environment. So recycling 1,000 kilograms of paper will save us 24 trees. If 24 schools each recycle 750 kilograms of paper, then the total number of trees this will save is, so it's just about having that relationship between the kilograms of paper and the trees saved, which I think is extremely easy there, as we shall justify in our working. Question 4 tells us a quiz included 50 multiple choice questions. Stella's score was calculated by adding 4 marks for each correct answer, that is okay, subtracting 1 mark for each wrong answer. So the examiner penalizes Stella or indeed any other student for any wrong answer, and then adding 0 for each unanswered question. Stella answered 45 of the questions, of the 50 questions, and her score was 135. The number of questions Stella answered wrongly was, we have to form a basic equation there. Question 5, I obviously don't sense any trouble in number 4. Question 5, calf X and calf Y are growing at different but constant rates. Calf X's mass is 12 kilograms and she is growing at a rate of 2 kilograms per month. Calf Y's mass is 6 kilograms and she's growing at a rate of 2.5 kilograms per month. What will calf X's mass be when it is equal to calf Y's mass? Obviously, we can see that calf X has a bigger mass than calf Y. However, calf Y's mass is increasing at a higher rate than calf X. So eventually they'll have to catch up. So what will calf X's mass be when it's equal to calf Y? Of course, when it is equal, it is equal. Whether you come through the angle of doing calf X's mass, it will be equal to calf Y's mass. Or if you get calf Y's mass, it will be equal to calf X's mass. So that is simple. Once again, question 6 here says, Rita and Anita left town A at the same time and drove on a highway towards town B, which was 200 kilometers away. Rita drove at an average speed of 50 kilometers per hour. Anita drove at an average speed of 60 kilometers per hour. So Anita is actually moving faster. So we expect her to reach before Rita. Then what happens? But Anita stopped along the way to buy roadside eats and drinks. They both arrived at town B at the same time. So clearly here we can see that Anita, despite moving faster, wasted some time. And what was the result? They arrived at town B at the same time. Question: how long in minutes did Anita stop to buy roadside eats and drinks? So we have to do a simple calculation there. That one is testing my knowledge of relationship between distance, speed and time. That is all. That is all, nothing more from the question there, as we shall see in our detailed calculation. Question 7. The digits continue to repeat. The digits in 1/7 continue to repeat. The third digit, the digit in the third position to the right of the decimal is 2. We can confirm that indeed 2 is in is the third position to the right of the decimal. In which of the following positions to the right of the decimal point will there also be a 2? So we have to develop a pattern and realize where the 2 is. Since this is a recurring decimal, the position of 2 is constant. Once we establish that position, we can form a simple sequence, perhaps develop a pattern, and be able to know the position of 2 in, even if you ask me 1 million, we shall be able to know the position of 2 as long as we develop that pattern. Anyway, the examiner has given us answers in the range of 200, 200 there, 213, between 239 and 246. We shall find which of those answers passes. Question 8, a piece of paper is folded in half creating 2 layers. The paper is then folded again, creating 4 layers, and so on. So it will keep on 4 layers. From 4 layers, I imagine there will be 8 layers, and so on. So we have to find the relationship there. This is continued until the paper has been folded X times. So the examiner is introducing in X now to develop a relationship between the layers and X. The total number of layers of paper in folded sheet is that relationship. We shall also be able to find that together as we draw closer to the end of our overview before we start the detailed calculation. Question 9. There are 3 times as many boys as girls in a room. That is okay. If 4 boys and 4 girls leave the room, there will be 5 times as many boys as girls in the room. In total, how many boys and girls were in the room originally? Now, for this kind of question, we can form an equation and solve it. But what I advise most of my students to do, if you cannot form the equation, just look at these answers. Just try to sort of prove these answers. If you're given this statement and you're told there are 3 times as many boys as girls in the room, and then they're asking you how many boys and girls were in the room originally, they're asking you for the total number of boys and girls in the room. The best approach you can use is to just test, as we shall be able to see. If there are 3 times as many boys and as girls in the room, sort of form ratios there. It means the ratio of boys to girls is 3 to 1. So the fraction of boys is 3 out of 4, and the fraction of girls is 1 out of 4. And then you keep on testing them on these answers. For example, I see if I apply 3 out of 4 to this first answer, if I apply 3 out of 4 to the first answer, I'll straight away get a decimal answer there, because 15 divided by 4 is about 3.75. When I multiply that by 3, I'll still get a decimal. So straight away this answer cannot pass, even without me forming an equation. And I'll keep on moving until I get the correct answer. But we shall do both methods anyway. Question 10. The width of a rectangle is doubled and the length is halved. This produces a square with perimeter of p centimeters. What is the perimeter of the original rectangle? There we shall form an equation. We may not avoid an equation there. So let's go straight into the dynamics of the calculations. There. So question 1. See, we can begin having the solution. Question 1. 6 towns A, B, C, D, E, and F are equally spaced on a straight path. First of all, the first thing for me to know, we have 6 towns, but how many points are there? First of all, from town A to town F, we have A to B, that is the first point. Then we have B to C, that qualifies for our second point. Then we have C to D, that should be our third point there. Then D to E, that's our fourth point, and E to F. That is the first point. Those are the first five points. And then, of course, after having our first 5 points there, then we go back. First 5 points there for us. and we make the return journey, I could actually just increase the font of everything there for us to be able to see clearly for all our viewers. Having done that, what is the return journey? We have point F to point E there. We can list all of them before answering the question. Then we have point E to point D. We are making a return journey there. Then we have point D to point C. And then we have point C to point B. And then finally, we have point B to point A. These are qualified to be our next 5 points. So if those are our next 5 points, we can get back to the question. Joan drives from town A to town F and then back to town A, exactly as we have showed. At what point would she have completed 70% of her drive? Now, from A to F, we have 5 points. And then from F to A, we have 5 points. So what is our total number of points, first of all? Total number of points. Total number of points is simply the 5 points for the 2 journey and the 5 points for the 4 journey. So these are a total of 10 points. Now, if we have 10 points, the question is asking us, at what point has she completed 70% of the drive? So 70% of the 10 points, how many points are those? These are 7 points. So the question is simply asking us, at what point has Joan covered 7 points? So the first 5 points, those we know. So the next 7 points, the 6th point after the first 5 will be F to E, and then the 7th point will be E to D. So at what point has Joan covered the first 7 points? There we have point D. There we have point D. We have point D there, which passes which point D? We have point D. We have point D there, which passes for our answer, and hence we can bold that option. We can bold the option of point D. So that was question 1, which was extremely easy, very easy option for us there. So we can continue to question 2. I think that was very easy, very kind of the examiner to give us such a question to begin with in the numerical skills section. Question 2, we can begin there with the solution. Question 2 says, question 2 tells us, Kato bought 3 lemons. So I can just note there, Kato bought 3 lemons, 2 oranges. We can use the addition sign there, plus 2 oranges, plus 1 mango there, for 10,000 shillings. So all that is equal to 10,000. Waswa, we can just specify this was Kato, just to keep track. The next person is Waswa. What happened to Waswa? Waswa bought 1 lemon, so we can say 1 lemon there, put the addition sign, plus 2 oranges, plus 3 mangoes. How much did he spend? He spent 7,200 shillings. What is the question? How much? What is the question? How much in shillings does it cost to buy 1 lemon, 1 orange, and 1 mango? So the question has given us 3 variables: the lemons, the oranges, and mangoes. For Kato also, lemons, oranges, and mangoes for Waswa. And it's also asking us about lemons, oranges, and mangoes for a unit price. Now this is the kind of question that you need to kind of brainstorm. Now, if they're asking us for a unit, one lemon, one orange, and one mango, we have to establish a relationship between the three variables. How do we establish a relationship between these three variables? I'm not going to eliminate anything. My best interest is to add them. For example, if we add, I'm also going to come back and I give you another scenario. If we add Kato and Waswas purchases, the lemons together, we shall have 4 lemons plus 4 oranges plus 4 mangoes, which will be equal to the total, which will now be 17,200. So you can see we have managed to have one unit price, and it goes without asking that the common factor is 4. So if we divide by 4, we shall surely have 1 lemon, 1 orange, and 1 mango. So it then means 1 lemon plus 1 orange plus 1 mango, indeed, as the examiner asks, is equal to 17,200 divided by 4. So it then means 1 lemon plus 1 orange plus 1 mango will now be equal to 4,300. And that was the answer to the question, which is option C. Option C there as our answer. Option C. Now, assuming the examiner had asked us, for example, had asked us there, how much would it cost? Let me just assume for you here. Assuming the examiner had asked, this is obviously a question I'm just making out just to try to ensure that my students my students understand. If the examiner had asked us for example, to let me just readjust the question very slightly indeed, just to emphasize my point here. Make some very slight alterations there for us. So if the question appeared like that, Kato bought 3 lemons, 2 oranges, and 5 mangoes. Waswa bought 1 lemon, 2 oranges, and 3 mangoes. If the examiner had asked us, how much would it cost us to buy 2 lemons and actually, let me adjust it slightly. How much would it have costed them to buy 1 lemon and 1 mango? Here, I straight away know that the examiner is looking at me eliminating the oranges. Now, if I'm to eliminate the oranges, there is no other option I have, but I have to subtract. And if I subtract, I will subtract 1 lemon from 3 lemons. So I will end up having indeed 2 lemons there, plus I'll also subtract the 3 mangoes from 5 mangoes, and I'll also have 2 mangoes. And this should lead me to the difference in that to be 2,800, the difference between 10,000 and 7,200. So I will end up as having 1 lemon. If I divide, indeed I divide by 2, 1 lemon and 1 mango will cost 1,400 shillings. Now, you can see this is the kind of very simple logic the examiner is testing. You didn't need to solve a 3x3 simultaneous equation, but just to realize that they have given me 3 variables and they're asking me for 3 variables. So what do I do? If they're asking me 2 variables, I have to eliminate 1 variable. It's supposed to be very easy. So that's how we would tackle such a question. Question 3 forms our next question. Of course, as we are having a review, we do them in order. But of course, when you are in the exam, it is your decision which question you want to do first and which one you want to do last there. You can decide to do the last question first and the first question last, as long as you transfer your answers correctly and not mix them up there. Question number 3 says, recycling 100 kilograms of paper will save 24 trees. Recycling 1,000 kilograms of paper will save 24 trees. If 24 schools each recycle 700, so we first of all have a relationship between the papers and the trees. So 1,000 kilogram we can say saves 24 trees. Let us continue with the question. If 24 schools recycle 750 kilograms, so we would like to know, even before we go deep into the question, how many kilograms are saved by the schools? How many kilograms are saved by the schools? So once we have that, we know that there are 24 schools there. So we have 24 times 750 kilograms of paper, of course. So when you multiply 24 by 750, you end up with 18,000 kilograms. So those are the total number of kilograms saved. Now, if we know the total number of kilograms, those are the total number of kilograms of paper. So we want to know, the question is asking us, then the number of trees, how many trees will be saved by the 24 schools or from the 18,000 kilograms. So this is a simple case of proportionality. So if 1,000 kilograms will save 24 trees, how many trees will be saved by 18,000 kilograms? So this is just as simple as saying 18,000 for us there, divide by 1,000 times 24, which by my calculator gives 432 trees. Of course, you can go the long way. You can go the long way there by saying, for example, 1,000 kilograms is equivalent. For now, I can just use the equal sign to take me quickly there. Is equal to 24 trees. So you want to know 18,000 kilograms is equal to X. Then, of course, by cross multiplication, you want to find the value of X, which is the number of trees. By cross multiplication, we have 1,000 X as being equal to 24 times 18,000. So the value of X will still be equal to what we had there before. Remember, multiplication is commutative, so the order doesn't matter. The order doesn't alter the calculation. So we have 24 times 18,000 all divided by 1,000, which would lead us to the same answer as we had in this equation. In this case, 432. In this case, 432. So we get back to our question and choose the option of B, which is 432 there. The only time 432 appears in our answer. And so that is our answer. Let's go to the next question, which is question 4. Maybe I'll just increase the font size of the solution. It's a fairly worded question there. I just increase the font of the calculation there. So question 4 says, a quiz included 50 multiple choice question. So in this quiz, we are talking of 50 multiple choice questions, which can be abbreviated as MCQs, 50 MCQs. So Stella's score was calculated by adding 4 marks for each correct answer. 4 marks for each correct answer. So what do we have there? We can say, let the correct answer be C. So by default, the wrong answers, if I may use that, the wrong answers or the incorrect answers there will be W. We can continue. So they were adding 4 marks for each correct answer for Stella and subtracting 1 mark for each wrong answer. So what would be the correct equation for Stella's mark? And also, by the way, adding 0 for each unanswered question. So that is like having no impact. So we were having 4 marks times the number of correct answers. So here we should have said, let them, can we just adjust that, number of correct answers be C. Then that means the number there of wrong answers will be W. So for C, 4 times C, of course, minus 1 into W, if I may say that, which will end as W anyway, will still end as W there, will be equal to Stella's mark, which is 135. We also know that the correct answers plus the wrong answers, that is C plus W there, shall be equal to the total number of questions that Stella answered there. Now, I didn't add the 0 because 0 has no impact. 0 has no impact. So let me just solve the equation, then I'll also show you another way of doing this question. In fact, probably I should have started with that, but let me just finish. This working for us here. So we have two equations, and the first equation here will simplify as 4C minus W being equal to 135. So we are interested in finding, at least per the question, the number of questions that Stella scored wrongly, that is W. So from here, we could make C the subject and substitute so that we remain with only W. C here will be equal to 45 minus W. So this allow me very kindly to call this one equation 1. I'll also show you the try and error method. Don't worry if you don't like equation 1 and equation 2. So by substituting there, by substituting equation 2 going into our equation 1 there, what shall we have? If we put equation 2 into equation 1, we shall have 4C. 4C will now be 4 for us there into C. We just said C now is 45 minus W. So 4C minus the W itself is equal to 135. So when we solve this equation, we shall have the wrong W, which is the number of wrong answers, and we shall put it straight there into we shall get the answer and choose the objective. So by simplifying, 4 into 45 is 180 minus 4 into negative W is minus 4W minus this should maintain the capital there, minus W will be equal to 100 and will be equal to 135. Is it so? Yes. So if we simplify this equation, when the 180 comes the other side, when the 135 comes this side, we shall have 45 is equal to 5W, and then W by division will be equal to 9. So we have our number of wrong answers as 9, for which we go for option D. When you get the correct answer, it's quite easy to identify it there, and so we go for option D. So that is a simple case of substitution. Now the second method which I was telling you, maybe I could put it here, is the try and error method. If you realize that you're not able to form this equation within the exam, but you have interpreted the question rightly, then go for the try and error method. Let's take an example. Using the try and error method, you have to test these answers from any order you want. You can decide to start from behind here, or you can decide to start from the first. Let us start from the first. So option A, we shall know whether it is correct or not. Option A says the number of questions that Stella would have answered wrongly is 41. So if Stella has answered 41 wrongly, we can put that. So we can say the wrong ones are 41. If Stella has answered 41 wrongly, and remember Stella did only 45 questions, it then means her correct answers are 4. What would be Stella's score? Stella's score would then be the correct answers, that is 4 times 4, then minus the wrong answers times 1. So 1 times 41 there for us, which is 16 minus 41. 16 minus 41, which I think gives us negative 25. So that is wrong. That is wrong. Stella scored 135. She didn't score a negative 25. Let's continue to option B in this try and error method. The next one tells us the wrong ones are 40. If the wrong ones are 40, what are the correct ones? The correct ones are 5. If the correct ones are 5, what would be Stella's score? Stella's score would once again be then the number of correct ones, which is 5 times the score of 4 minus 1 times the wrong ones. So 1 times the wrong ones here is just 1 times 40. Again, I see this leading us to a negative, because it is 20 minus 40, which is negative 20. Nobody told us that Stella got a negative, so that one will not work. Let's see option C. Of course, we know the option is D, but I'm just showing you how to get it in the try and error method. As long as you have understood the question anyway. You understood the question, but somehow you are unable to form the equation. That's okay. Go on with the try and error method. The answers are all facing you. The next one, Stella got 15 questions wrong. So the wrong ones for Stella in this scenario are 15. If the wrong ones are 15, the correct ones are the remainder. It means that the correct ones are 30. What would be Stella's score in that case? Is it 135? Let us see. So if the correct ones are 30, we again have 30 multiplied by the score of 4 minus 1 times the score times the 15 wrong ones. I see that leading us to 120 minus 15, which is 105. Nobody told us that Stella got 105. Then we go to option D. So option C is wrong. Option D tells us that Stella had the wrong ones were 9. If the wrong ones were 9, how many were correct? If the wrong ones were 9, it means that the correct ones were 45 minus 9. So if we have 45 minus 9, those are 36, which were correct. What would be Stella's score? Stella's score would be 36 there for us, times the times 4, the square of 4 minus 1 here times 9. And I see that leading us to 144. I could put that because the correct option minus 9, which is 135. So there we are. Stella's correct score is got 9 wrong, and she got a score of 135. So that is pretty easy as long as you can interpret the question. Let's go to question 5. Let's go to question 5 there. Question 5, create some working space for us there. Question 5 tells us, calf X and Y are growing at different but constant rates. The rates are not the same, but they're all growing constantly. Okay. Calf X's mass is 12 kilograms and she is, we could note there. So we are dealing with, first of all, two calves, calf X and calf Y. So what is so special about each of these calves? The question is telling us calf X's mass is 12 kilograms. So we have the mass here for calf X as 12 kilograms, and she is growing at, we could just note that, is growing at 2 kilograms per month. That is all to do with calf X. And calf Y's mass, we could also, we surely should also, note that this one is also growing. The mass here, first of all, is 6 kilograms. But we are told calf Y is growing at 2.5 kilograms per month. So now we can see, even before we get to the question, that calf X has a higher mass than calf Y. But calf Y's mass is increasing at a higher rate than that of calf X. So at some point, the mass of calf Y will have to catch up with the mass of calf X. What does the question tell us? What will calf X's mass in kilograms be when it is equal to calf Y's mass? And I told you in our overview that whether you get the mass of calf X or calf Y at that point when they are equal, it will give the same answer because the masses will be equal. So how do we tackle this question? If first of all, we need to know the difference because their masses are not the same, despite us being told that they are growing at constant rates, but the rates are different. Anyway, difference in masses of calf Y and calf X. I need to know that before I figure out what to do with the question. You need to guide yourself that way. So the difference is 12 kilograms minus, pardon me, they are small, supposed to be small letters, minus 6 kilograms, which is 6 kilograms. Now, we want to know how long will it take calf Y to catch up with this difference of 6 kilograms. So, we want to know each month, what is the difference? Each month, how many, what is the difference in the growth rate? So each month, each month's difference, if I could say it's that way, each month's difference in growth rate. If we are to find the difference in the growth rate, we shall have to say 2.5 kilograms, kilograms there, kilograms per month actually, that we could just maintain that, minus 2 kilograms per month, which by my calculation is 0.5 kilograms per month. So each and every month, calf Y is catching up on calf X at a rate of 0.5 kilograms per month. Per month. So the question is, how many months will it take calf Y to catch up with calf X? So how many months will it take? Will it take calf Y, that was the calf with the lower mass, calf Y to catch up with calf X there? This is just the same as dividing the difference in the weight by the difference in the growth rate. So this will be 6 kilograms divided by 0.5 kilograms, if I may say so, per month. So this will give us an answer in months. This will give us an answer in months. And so this will be 12 months. If you divide 6 by 0.5. Now in those 12 months, what has happened? They have the same mass. So even if I calculate using the mass of, what are their masses after 12 months? After 12 months. Calf, we can start with calf X. I told you they will be the same anyway. Calf X will now be equal to 12 kilograms plus 2 kilograms per month, if I may say so, times the 12 months we have talked of. So this will be 12, is it so? Will be 12 there plus 12 plus 24. 12 plus 24 there, which is 36. How about calf Y? If we decide to go through calf Y, we shall still have 6 kilograms plus 2.5 kilograms per month there, 2.5 kilograms per month times the 12 months, if I may say so. Just include here months, and not so important, but could guide us not to confuse. So this will end in us having 6, of course, kilograms plus 2.5. 2.5 times 12, I think, is 30. So this will end in 36 kilograms there. So whichever option you go through, the answer will be 36, for which we have to choose our option A as the only answer with 36 there for us. And so we can conclude that the answer to this is letter A. So we can rush through the next question, which is question 6. Question 6 there, fairly worded question, but nothing much. There a long question, so I will only increase the fonts of my solution there in order not to take up the whole screen. So question 6 says, Rita and Anita left town A at the same time and drove on a highway towards B, which is 200 kilometers away. So psychologically, we know that we are dealing with two people. The first one is Rita, the second one is Anita, and the distance we are discussing about is 200 kilometers. So this is a case, as I said, if you look at the question, they are saying Rita drove at an average speed of 50 kilometers per hour. So as long as I see 50 kilometers per hour, that is the speed there. So I'm already gearing up for the relationship between speed, distance, and most probably time. Let us continue. Anita drove at an average of 60 kilometers per hour. That is not all, but stopped along the way. Anita stopped along the way to buy roadside eats and drinks. So Anita stopped. And it goes without saying that Anita wasted some time, thereby using more time on the road there and reaching much later than she should have arrived. They both arrived at town B at the same time. This is quite important again. They arrived at the same time. Their time of arrival. What's the question? How long in minutes did Anita stop to buy the roadside eats and drinks? So as soon as I see such a question, and I know that Rita moved straight away, I am immediately tempted to first calculate the time taken by Rita. So time from the old relationship, time, what's time? Time is equal to distance over speed. Or you could, depending on how you've decided to memorize it, you could actually as well say distance is equal to speed times time. Now, if you have that equation, what is the time taken by Rita? So I'm calculating time there for Rita is equal to the distance of 200 kilometers by all means, divided by her speed of 50, which is 4 hours. If you divide 200 by 50, you'll end up with 4 hours there. Now, if I have got those 4 hours, I also want to know how long was Anita expected to take, because I now have the time that it has taken. So the time taken by Rita is actually the same as the time taken by Anita, because they arrived at the same time. So they have all used the 4 hours. But as Anita took 4 hours, what was the time she was supposed to take? So we can say time supposed to have, pardon my long statement, I'm really trying to make you people understand. Time supposed to have been taken by Anita. Not Anita here, Anita is supposed to be equal to 200, the distance. Of course, this will also be equal to distance over speed. So the distance of 200 over her initial speed, if she had not stopped, of 60. And this, by my calculation, gives 3 and a third. 3 and a third there. Now, let's have that written, 3 and a third hours. So that's the time she was supposed to have taken, but she took 4 hours. So the question, we could slightly peep back at the question. How long in minutes did Anita stop to buy roadside eats and drinks? So this is the same as asking us, how much time was wasted by Anita on her initial projected time? So we can say time wasted by Anita is now the difference between the 4 hours she took and the 3 and a third hours which she was supposed to take. And this gives me, if I am not wrong, gives us 2/3 of an hour. Now 2/3 of an hour, remember the question asked us how long in minutes. So we have to convert 2/3 of an hour into minutes. So time in minutes, this is easy for everybody, for each of us there doing the pre-entry we have no difficulty converting 2/3 of an hour to minutes. So since we have no difficulty, we shall only say this is 2/3 times 60, which in this case is 40 minutes there for us, 40 minutes. So that is the time taken, the time which was wasted taking to buying the eats and drinks, and therefore our answer is option B. Let's rush quickly to question 7. Question 7 for us there. Question 7. We can have the solution. So you can realize that these questions, as I always say, it's about having a little calm within yourself, and once you have that calm, then you're obviously able to succeed in this very, very, very basic math that we are doing. You can look at, for example, the first questions which we have done. It's just simple logic, nothing more to go beyond. I've not seen any operation more than addition and multiplication sign. So that is a good sign for us that this is a very passable exam. This is a very passable exam for us, as we keep on emphasizing. This is a very passable exam. So question 7, the digits. The 6 digits 1, 4, 2, 8, 5, 7 in the fraction 1 over 7. What are those 6 digits here? 1, 4, 2, 5, 8, 7. Indeed, I can see 6 digits before they recur. Continue to repeat. The digit in the third position to the right of the decimal point is 2. I can see that. We don't dispute that. In which of the following positions to the right of the decimal point will there be a 2? Now, this is a simple type of question where you need to lead yourself. You really need to lead yourself there in the exam. If first and foremost we are looking at the position of 3, of 2. 2 is in, first of all, is the first 2 is in the position 3. In which position is the next 2? The next 2 here I see is in position number 9. After position number 9, the next 2 is in position number 15. So this is enough for us to establish a relationship. So we can see that the first 2 is in which position? Is in the third position. The next one is in the 9th position. The next one is in the 15th position. So what is the relationship? The first relationship is that we have a difference of, that difference can be got by saying 9 minus 3, which is 6. It can be got by saying 15 minus 9, which is 6. So if the difference is 6, we have to establish a pattern. So the first position is 3. The next one, the second position is 3 plus 6. The third position, so we can see that after subtracting 3, we must have multiples of 6. The third position is in 3 plus 12. But I can also say 3 plus, because 12 is 2 times 6. So I can say 3 plus 2 times 6. Now once we have that, we have already established a relationship. So the question is asking us, in which of the following positions to the right of the decimal will there be a 2? So I realize that if I am adding, for example, if I want to test for example, the next position, and then I say position of 16. I want to know whether there will be a 2. Of course, I know there will not be a 2 at 16 because we have a 2 at 15. If I want to test the number 16, what will I do? I will first of all know that since here, to arrive at this position, okay, let me start with 15. If I want to indeed confirm that there is a 2, position of 15, what will I do? I will say 15 minus 3, because here we're adding 3, now we are going backwards. We say 15 minus 3 divided by 6. So this is 12 divided by 6, which is 2. So as long as this is a whole number, I know it passes, there will be a 2. Let us look at the position of 16 before we go to the numbers in the 200s. Position of 16. Once I say 16, we are going backwards, remember, minus 3. And then I divide by 6. First of all, 16 minus 3 is 13, and 13 is not divisible by 6, so we get a decimal. So we straight away know that there will not be, a 2. So let us go for these numbers. Let us go for these numbers that we are given in the exam. I didn't want to use any complicated equation. So let us just test the numbers. I beg we use this simpler equation. Of course, I could establish a sequence and say at such and such a position, this will be the position for the first n, this is the position for the second n, and so on. And then we come up with a formula. Completely not necessary. We have the answers. We are basically testing them. So let us start with the number, the option A of 246. What will happen to 246? If we say 246 minus 3, as we have done here, divide by 6. When we get 243 is not divisible by 6, so we get a decimal, so that doesn't pass. The next, 245. If we say 245 minus 3 divided by 6, 242 divided by 6 also gives a decimal, so that is not the answer. 243 is our next in line. 243, when we put it into our formula, 243 here minus 3 divided by 6 is 240, which is divisible by 6 to get 40. We get 40. And since that is not a decimal, this one would pass as the correct answer, coming through there with option C. I don't need to go to D and E. There we are. So let's move on to question number 8 as we move towards the end. Question number 8, not too long, very interpretable, and it says a piece of paper is folded in a half. A piece of paper is folded in a half. So what do we have to know? If a piece of paper is folded in a half, it creates 2 layers. The question tells us so. A piece of paper is folded in half, creating 2 layers. The paper is then folded in half again, creating 4 layers. So what should we say? On the first fold, what do we have? We have 2 layers. What happens? On the second fold, what do we have? We have 4 layers of paper. That's the farthest the question goes. This is continued until the paper has been folded in half 4x times. So they're introducing a new variable, x. Here comes the question. Then in the last statement, of course, the total number of layers of paper in the folded sheet is in terms of X. So they want us to find the relationship between X, the number of folds, and X. So I assume if we had folded again the third time here, let's just do a third and fourth time, we would have 8 layers. If we had folded it for a fourth time, we would now have 16 layers. So they want us to find the relationship between X, between the number of folds. So if we have that, if the paper has been folded X, and first of all we know if it is folded once, we have 2 layers. What is the relationship between, in terms of 2, the powers of 2? If we fold the first time, we have 2, which in my by my observation will be 2 to the power 1. If it is folded a second time, it will now increase to 4, which is 2 to the power 2. If it is folded the third time, it will now go to 2 to the power 3. That's as simple as the question is getting. The third time will be 2 to the power 3, and the fourth time is 2 to the power 4. Now, if it is folded X times, how many layers of paper shall we have? X times, it goes without saying that for X times we shall have 2 to the power X layers of paper. 2 to the power X X times we shall have 2 to the power X layers of paper. Now if we have 2 to the power X layers of paper, that surely should answer our question. And 2 to the power X here, the total number of layers of paper in folded sheet is 2 to the power X. There will be our answer. So having given us that background, they wanted us, having given us that background, they wanted us to have a relationship now between X, for which 2 to the power X passes there, meaning that our answer is option A. Question 9, as we draw nearly to the end, we are very nearly finishing this 2019 pre-entry numerical skill section there. So our solution once again. Question, this one says, there are 3 times as many boys as girls in a room. If 4 boys and 4 girls leave the room, first of all, if they are telling us there are 3 times as many boys as girls in the room, I always encourage my students to use ratios. If you have the chance, use ratios. So if they say that there are 3 times as many boys as girls, it means the ratio of boys to girls. We are capable of finding that ratio. If there are 3 times as many boys as girls, it now means that ratio for now is 3 to 1. If the ratio of boys to girls is 3 to 1, we can also get the fraction. It then also means that boys are 3 out of 4. Of course, by having the total there. Can I just emphasize there what my total ratio there for the denominator of the fraction is, which is 3 plus 1, and that is 4. So the fraction of boys is 3 out of 4. If the fraction of boys is 3 out of 4, it goes without saying that the fraction of girls is 1 out of 4. If the fraction of girls is 1 out of 4. Let us continue with the question. If 4 boys and 4 girls leave the room, then there will be 5 times as many boys as girls. Can we have that? If 4 boys and 4 girls leave, there will be 5 times as many boys as girls. So this is as good as saying, now the ratio is as good as saying the new ratio, if I may just say that, the new ratio will now be after this incident has happened here. I could just put it in italics there for us to take note. What will be the new ratio? The new ratio now of boys to girls, will now be 5 to 1. The new ratio of boys to girls will now be 5 to 1. And then also it goes without saying that the fraction, what will the fractions be there? The fraction will be boys at the total, once again, we could find the total there, the total ratio, this time being 5 plus 1, which is 6. So the fraction of boys in this case will be 5 out of 6, and the fraction for girls will be 1 out of 6. Now, having had that, what is going to happen? We now know we can actually test. The question is asking us in total how many boys and girls were in the room originally. So it's asking us how many people were in the room originally. The easiest method, which I'll use as the first method for this, is the try and error method. The try and error method simply means look at the answers and test them. If they say how many boys and girls were in the room, first of all, there were 3 times as many boys as girls in the room. So the first answer of 15, I am going to use trial and error. Of course, I'll later use an equation there, but some people may not be comfortable forming the equation, especially within the real exam duration, with the exam pressure and everything. So the first answer is 15. So we want to test the option of 15. If there were 3/4 of boys at first, then we test can we get 3/4 of 15? If we cannot, we move on to the next option, because if we have 3/4, we will then have a quarter. So let us attempt to find the number of boys. If the total of people were 15, what would be the number of boys? The number of boys here would be 3 out of 4 times 15. 3 out of 4 times 15, which gives a decimal answer. Of course, we cannot have students in decimal. So this automatically means that A is wrong. Option B, can we go for option B? What would be the implication of option B? Well, with option B, let us have 20. We see, if we have 20, what would be the number of boys? First of all, the number of boys. Do I need to emphasize initially before whatever happened? The number of boys will be 3 out of 4. 3 out of 4 for us there times 20, which gives us 15. That is okay. Let's continue investigating. This doesn't mean yet that it is correct. So if we have 15 boys, it then means the number of girls we have are 5. Let us continue. If 4 boys and 4 girls leave, can I just copy that? If 4 boys and 4 girls leave, what is going to change? What is going to change if 4 boys and 4 girls leave? First of all, it means the number of boys. What will be the number of boys? The number of boys here will now be, can I just say new number of boys? We are dealing with a change in our number. New number of boys will be the whole number of boys of 15 minus 4, which is equal to 11. That's okay. But it has to be a certain fraction. This 11 must be 5 out of 6 of the total number. If it doesn't, then we have a problem. It's not correct. What will be the new total number of, can I say students? New total number of students or people in the room. It's not a big deal. What's the new total number? The new total number now will be 20 minus, remember 4 boys left, 4 girls left, so these are 8, and so this is 12. Is it so? When we say 11, so what is the fraction? 11 over 12. Of course, 11 over 12 is not 5 over 6. So that is wrong. We go to option C. What is option C? Option C was 24. What happens with the 24? First of all, what happens with the 24? What is the number of boys? Number of boys. Of course, initially, remember the boys were 3/4. So the number of boys initially will still be equal to 3 out of 4 times 24. 3 out of 4 times 24 is equal to, what do we have there? Is equal to 18. Now, this then means the number of girls is the difference, which is 6. No problem about that. No problem about that there. Nobody disputes that. But let us continue. The challenge is if they leave. If they leave, will this represent 5 out of 6 or not? Let us see. So we now want new number of boys. And now they have left, so the boys are less. Okay, new number of boys will be the whole number of boys of 18 minus the 4 who have left, which is 14. No problem about that. What is the new total? The new total will be the whole total, which is 24, minus the 4 boys and 4 girls, which is 8, and 24 minus 8 gives us 16. What is the fraction of boys? Fraction of boys there will now be equal to 14 out of 16, and this is not 5 over 6. So let's go to the last option there before we can settle for none of the before we can settle for none of the above there. Option D. What is option D? Option D was 32. Let's examine 32 before I give you the equation that you can just form once and get the correct answer on which to pick. For 32, what was the initial number of boys? Initial number of boys was 3 out of 4 times 32. 3 out of 4 times 32. 3 out of 4 times 32. That is it. I think that should give us 24. What would be the number of girls? Number of girls there. Number of girls, of course, would be the difference, which is 8. Now, once we have that, we are able to proceed. So once again, if the 4 boys and 4 girls leave, what is going to happen? How is it going to affect our proportionality? If they leave, remember we just decided to use the number of boys, and we just keep checking the proportionality. So the new number of boys, what will this be? The new number of boys will be 24 minus 4, which is equal to 20. what would be the new total? The new total would be 32 minus the 8 we have left, which is 24. Now, what is that fraction? This is our last option, otherwise we go for none of the above. Our fraction will now be 20 out of 24, which simplifies to 5 out of 6. So meaning that the option of 32 is the correct one, and we can go and choose 32 was the number of people in the room initially. Now, this is try and error. We can just use the equation. So if we have succeeded in that try and error, let us use the equation. This is method 2. I must, can I just label this as method 2? If I've labeled this as method 2, it also means I have to go up and label the other one as method 1. And the one we labeled trial and error. Where did I put that? Okay, there we are. This is method 1. So method 1 has got us the answer. We just want to see method 2 using the equation. Now remember, in the question, we have discovered that 3/4 were boys. So the question asking us how many people are in the room. So let the total number, of course it asked for boys and girls, those are the total number of people. Let the total number of people in the room be X. Now, if the total number of people in the room is X, initially the boys were 3/4 of X. So can we say this? I am looking at how to simplify the equation. Initial number of boys was 3 out of 4 of X. So if the initial number of boys was 3 out of 4 of X, it also means the initial number was X. So what happened? From the 3 out of 4 of X, which was the proportion of boys, we subtracted 4. And from the X, which was the total number, we subtracted 8, which was 4 boys and 4 girls. So when we subtract 4 from the numerator, which was the number of boys, and we subtract 8 from the denominator, which is the total number, we get 5 out of 6. So we can then form our equation, which will give us the answer directly. We can then form our equation, which is going to give us, our equation there is going to give us the answer directly. Our equation is going to give us the answer directly. So if we have that, it then means, what did we have? At the numerator, we had, at the numerator, pardon me there, can just have that once again. So I have to just insert the equation there. We have to really insert the equation there for it to be able to accept us there. It's proving to be a bit of a process there. But we had 3 out of 4. So we can just say 3 out of 4x there minus 4 divided by x, the total number, minus 8, and all this should be equal to 5 out of 6. And there is our magical equation that if we solve, we definitely have everything right there. So by cross multiplication there, by cross multiplication, it then means we are going to have 6. Could just insert insert the equation there. We could have we have 6 into 6 there into 3 out of 4, 3 out of 4 x minus 4. This will be equal to 5 into x minus 8. So once we have that, we shall now end up having 18. If I just simplify that as I run through, 18x divided by 4 minus 24 is equal to 5x minus 40. So when you simplify this, you'll get 4.5x minus 24 is equal to 5x minus 40. By collecting like terms, we have the 40 coming this side, and then the 4.5 going the other side. We have 16 is equal to 0.5x, and x is equal to 32. If you simplify that by dividing 16 by 0.5. So that is the method of the equation. You only need an input in forming this equation. Solving it is not difficult. So we go to the last question, and last question, question 10. As our recording has really got long, we can have the solution for that. Now question 10 says the width of a rectangle, is doubled and the length is halved. So what are we saying? The width, just increase the font there. The width is doubled and then the length. So width is 2w, and then the length is half. So the length is L over 2. Now, if the width is doubled and the length is halved, this produces a square. So the width was much shorter than the length, or the length was much longer than the width. So when the length was divided and the width was doubled, we get a square, for which the perimeter of the square is 4s. Perimeter of square, perimeter of square is p. But before we even go further, we know that perimeter of a square at least is equal to 4s. So it means that where s is the number of sides, it then means s here. Here now perimeter p, I could add that, is equal to 4s. So it then means s is now equal to p over s is equal to p over 4. P over 4. Now we have one side as p over 4. Now if one side is p over 4, what is the question asking us? What is the perimeter of the original rectangle? And all the answers I see are in terms of p. So they want the perimeter of the original rectangle. Now the width is the width. Remember now, all these, the length and the width all become the side of the square. So the initial width, which was 2w, if you may allow me to say so, is now equal to P over 4 is equal to P over 4. Now, if the width is equal to P over 4, in a similar manner, the length, which in this case was L over 2, the length was L over 2, length there was L over 2, we have that L over 2 there, and this length is also equal to P over, the length is also equal to, that length can also be equal to P over 4. Now, what was the perimeter of the original rectangle? That is the question. Now, we also know from our primary school that perimeter of a rectangle, I must specify, is equal to 2 into L plus W, the famous 2 into length plus width. So when we have that, we now have the length, and then we also have the width. Now, if here we make W the subject, the original width, that W will be equal to, but when we divide P over 4, when we make W the subject, we shall divide this by 2. So it will be a half of P over 4 there. So a half of P over 4 will give us P over 8, because the other 2 goes down here to the denominator. And also here, if we make L the subject, what will L be equal to? L will be equal to, so we'll cross multiply, the 2 will go that side, so we shall have 2P over 4. And 2P over 4 will simplify as P over 2. So when we enter that, the different length of, remember we are concerned by the original rectangle, the perimeter of the original rectangle will now be equal to 2 into the original length. We can just keep that order there, which is P over 2 plus the original, sorry, this is P over 8, pardon me there, I didn't correct that, because P over 4 divided by 2 is surely P over 8, but anyway, the length here is P over 2, we transfer it here, and then the width is P over 8, which should draw us towards the end of this question. So if we have those, by collecting terms, like terms, or simply adding a half to 1 over 8 on your calculator, what do we have? What do we have there? What will be the LCM there? The LCM is 8. If you like to go through the long method of LCM, we shall have 8, and if we have 8, the 4p, the p over 2 times 8 will now become 4p, and then the 8 will remain as 8 there. Sorry, the p there will remain as p, which will simplify to, we can have that simplified version. That will simplify to 5p. This will be still be 2 into, this time now we have 5p there, divided by 8, which is supposed to be 5p divided by 4, simplifies as 5p divided by 5p divided by by 4, which in decimals, I don't see any answer in fraction. This will be very simply 1.25 p, and that is that surely is the perimeter of the original rectangle. So that is 1.25 p there, completing our choice of answers there with letter B. So that has been a detailed calculation and review of the numerical skills section for the year 2019. We continue to make these videos to guide you in your much needed preparation for the forthcoming pre-entry exams. My name is Numerical, your tutor for numerical skills, together with Mr. Richard Okoth at Ivory Tower Consults. Thank you so much for watching this video. I hope we shall meet again in many other videos to come. If you like our videos, kindly click the subscribe icon so that you can always get our latest videos. Thank you so much.